Okay, so here's the problems that you're gonna do now, graphing these piecewise functions. You're gonna have to understand how to do it here on Delta Math, and it's a little trickier because you can't just like draw the whole line and then try to erase it. It doesn't have an erase feature. Sorry. Like if I draw this one, like this one is f of x equals to 1 for this function on the bottom. By the way, it says click and drag to make a line, click the line to delete it, right? So you can make a line. If you just click, nothing's gonna happen. But if you gotta actually click a point and then drag to make a line, excuse me, and then you let go, right? But then I don't like it, so you can just click it to delete it. If I graph f of x is equal to 1, that's y is equal to 1. Y is equal to positive 1 is right here, is this graph. But then I gotta know the endpoint, which is the point where it's the point here on this interval where it's telling you that where you're gonna like start to erase. In this case, I have to go to x5, see? But I can't go here and then try to see. I can't click it and then I'll just erase it. We have to know the endpoint first. So I have to actually know this endpoint first and actually start there, click, hold it. And another thing you need to know is which direction you're going. Am I going this way or am I going this way from that 5, x equals 5? Okay, but just to show you, you get to click and you start from your endpoint, and then if it's going to the right, well then you kind of just go once or whatever, or twice. This one doesn't have a slope. If it needs to be an open circle, you click it once, okay, or you click it once. But if you need it to be like continuous, like for it to be going forever and ever, you click it again, and it kind of like it goes through that point and it's continuous that way. And yeah, just keep clicking it. There's only 3 things that are going to happen. It's either going to be solid when you click it first. When you click it again, it'll be open-ended. When you click it again, it'll shoot it across to the other side. But if you didn't mean to do that, you click it again. And again, if it's the whole thing wrong or it doesn't work out, just click the line and it deletes it, okay? So what I'm telling you here for Delta Math is you have to know this endpoint first. You see, so for this one, I know it starts at 5. It says x starts at 5. My line is at 5. And I know it starts at 5, so I'm starting here at 5. I'm holding it and I'm dragging it. But I have to know which way to drag it. I know this is a horizontal line. Okay, but I have to know that. And this is where you have to read it. Or I have to read it here, and it says, I want the values of x. Here's x5. But I want to see the graph where the values of x are greater than 5. Well, here's 5, and then here's 6, and then here's 7. That's how I need to go this way. Okay, and then it doesn't matter here which point you use. But again, since I want all the values greater than 5, remember to click it one more time, and then another time for it to go infinitely that way. And remember, it does not include the 5. It has to be a number. It doesn't have the equal sign, so see, that would be the one for that one. The trickier thing is going to be these other lines here where it's not a simple horizontal line. And this is where you're going to use Desmos, the graphing calculator. So what I'm going to show you here is we're going to actually go to Desmos and see where this point is at x equals -3. Okay, I want to see where the graph is when x is -3. Where is the graph? Where is the graph? That's what Desmos is going to do for you. It's going to do the graphing for you. So let me do that. Okay. So I got to open up another tab. I'm going to go to Desmos. All right, we're using the graphing calculator. And what was that function again? It was f of x is equal to -3x minus 6. negative 3x minus 6. Now, where's the endpoint? Oh, by the way, let's clean this up. You see, I don't want to see all these little grids, and I want my increments to be in ones, not in twos or anything else. So go to the little gear here and turn off the minor axis here, the minor grid line, sorry, the minor grid lines, just uncheck it. And now that's cleaned up a little bit, but it's going by twos. I don't want it to go by twos. So here on the x-axis, right here where it's a step, click it there and type the number 1. You notice the x's are now going by ones. 1, 2, 3, 4, 5. The y's are still not going by ones, they're going by twos. So now we're going to go over here to the y-axis, go down here, and also let's make that a 1. So enter 1. See, now everything's going by ones on the y-axis and on the x-axis. Okay, click out. So now I can see where this graph has like maybe a perfect point right there. Look, negative 2, 0. That's not a perfect point. It has to be a perfect point where the graph crosses the crosshairs of the grid. Yes, that's a good point. That's not a good point. That's not a good point. That is a good point. Let's click it and see. Is it? No, see it. Oh, is it? I think it is. It's on there. Okay, it is. That's another good point. That looks like it's another good point right there. Is it? Yeah, negative 4, 6. Okay. If you're not sure, you can always graph the point and see if it lands on the line. Let's see if I go negative 3, comma 3. Oops. We don't have to be like super precise, but sometimes the decimals is delicate. It looks like it's on there, see? So, anyways. So what are you gonna do? Oh, so I have this graph, right? Forget that point. That's not the end point. The point that you're interested in, the point that you are interested in is, let's go to the problem, right? We graphed it, negative 3x minus 6 is the end point. The end point has a x coordinate at negative 3. Don't worry if it's greater or less than. Go to x negative 3 and figure out what the y is. Figure out what the y coordinate is on the decimals, on where we graphed it. So go to x negative 3. Let me go back there. So it's going to graph it for you, and the end point is negative 3, right? Right here, whatever this value is, that's your endpoint. The value of x is negative 3. So I go to x, I go to negative 3, and I go to the graph. Oh, it's this one here. What is it? It's negative 3, 3. Okay, that's where you're going to start the graph. That's where you're going to click on Delta Math, negative 3, 3. You're going to click and start, right? You remember you got to click and drag it. But the problem is that I don't know if I'm dragging it this way or I don't know if I'm dragging it this way. So I'm just going to plot this point for now so you can see it. What is it? Negative 3, comma 3. Remember, this is our end point. Okay, you guys just keep that one in mind. I don't know if I'm going to keep the top part of this graph or I'm going to keep the bottom half of this graph. So I got to go back and look at that interval. But this is your end point, okay? Now, let's see what the problem says. The problem says that at negative 3, at that endpoint that we just got right now, negative 3, 3, they want to see the graph from x negative 3 and the values that are what? What does this inequality say? The values that are less than negative 3, less than or equal to negative 3. So here's x negative 3 right here. If this is negative 3, which way are the values of x that are less than negative 3? Well, this way, see? It would be this way, to the left. So that means I want to keep everything to the left of this point. That means I want to keep and go this way with my graph. Okay, I want to keep this kind of like this top part, top left part. I don't want this bottom part. But it's going to start at negative 3, 3. So what you need to know is, I already have this point. I know this point, negative 3, 3, my endpoint. What I need is another point on this side See, this is what the Desmos is going to help you find. Where is the next good point? Is that a good point? No. It has to be right in the middle of the crosshairs of the graph paper, right? The grid. So if you just keep going, no, that's not a good point. No, that's not a good point. Here's the other point that you need right there. You see, that's a -4, 6. So when you graph this on Desmos, you're going to start with your endpoint -3, 3, and then I need one on this side of it. I need one on this side, and the first one that's good, because that's not good, it's not on the crosshairs. It has to be right on the crosshairs, right? Wherever, right there. See, right there. Oops, what was it? -4, 6. I'm just typing it. You don't have to type it, but just so that you can see it, I'm typing it. So what you're gonna do is to graph it on the delta math, you're gonna click with your endpoint here, the -3, 3. And the next point you're gonna have to drag it to is to which one? This one, which is what? -4, 6. So again, you're gonna start with the -3, 3 on delta math, click it, hold it, and then drag it to where? To this one, to your second point, to -4, 6. So I can get this slope of this line. So let's do that. Remember, it's -3, 3 for the endpoint, -4, 6. So that's the first one. So that would be, what was it? -3, 3 is where I'm going to start it. That's my endpoint, and I'm going to hold it. And the other one's at -4 what? What was it? -4, 6 right there? Yeah. Okay, so we're going this way with the line. Now remember, it's continuous. Everything less than -3, all these numbers less than -3 are everything on this left side. So remember, you click it once and you click it one more time, and it'll shoot it out so that it's continuous for all the values of x that are less than -3. Okay, and should this be a filled-in circle at -3? Yeah, it has the equal sign. So it looks like I'm done with this one. Okay, I'm gonna do more and explain it, because using it here and dragging it and all that stuff. But remember, if you click it, well, when you first start it, it's a solid circle, and then you click it once, it turns into an open circle. You click it again, it'll extend. We don't want that. Click it again, it'll be back to a solid. Okay, let me submit this one. This one should be correct. Let's see, submit. Yes, and see, I got it right. All right, let me do one on the next video. So make sure, I'm going to do more, and they're going to be a little bit more complicated. So make sure you see the following videos. Okay, a little bit more practice. Here we go.